Welcome to my talk about some very in-progress work. In fact, I don't think my one-on-ones with David are on Fridays. So tomorrow we'll probably be talking about the same slides that I'm showing you here. Yeah, thanks. I'm going to talk about a project that I just started working on, looking at the ways that actors perform lines in movies. Generally, they're given a script to read, but their choices on how to read the line with emotion are what make the performance. And so I'm going to tell you about a computational pipeline I'm building to measure this idea of choice in delivery. But first, let's take a look at what I mean. As a warning, there will be a couple of video clips that have a lot of cuts. So just be prepared for that. Well, the audio kind of works. You're saying hi over and over again, if you can tell. But the idea here, hopefully, is that if you didn't believe me before, you believe me now that there's a lot of different ways to perform the same line. And so I'm going to present a data pipeline that I've constructed to try to measure the emotion in actor performance. And we'll talk a bit about where that data comes from, how I process it, some challenges of computational emotional recognition. And then I'll preview some very preliminary findings. And finally, I'll talk about some next steps in this project. So to start, this analysis requires access to a lot of movies. Fortunately, as some of you know, I have access to a large corpus of popular contemporary American films. Of course, I'm talking about my advisor, David Bandman's massive collection of movies and TV shows. Over the last couple of years, he's been buying and digitizing thousands of DVDs, and so I'm doing my analysis over a subset of those. Specifically, I'm presenting the analysis today based on a small set of 99 high-grossing American films, which were screen recorded and stored on our lab servers. This is a pretty small subset of the thousands of films that we'll eventually run the analysis on, which are stored on a secure cluster operated by the university because of legal things. So I'll talk a bit about what we want to get out of this data set, right? I want a mapping from a given phrase set like hello or hey there or hi to a set of all of its different deliveries in these movies. And I also want the associated emotions with which they're delivered. Intuitively, the phrase set is kind of this group of utterances, which we might expect to have the same emotional range of deliveries. Then for each associated audio clip of a given delivery, we can measure the emotion with which the actor actually chooses to deliver that line. There's a number of moving parts here. So if you have any questions about any specific piece, just let me know. But I'll walk you through kind of how the pipeline goes. So how do we organize a bunch of movies to get this sort of information? I construct two pipelines. One which processes the raw audio from the movies to find segments of speech, transcribes the text, and classifies the emotion. And the other clusters lines that are highly similar to each other, like thanks and thank you, into these phrase sets. So I'll talk about the audio pipeline first. To process the spoken lines in our movies, first we extract the audio from the movie MP4 file. Then we use a speech segmentation model to extract each utterance. We use Whisper to transcribe each utterance, and we use a speech emotion recognition model to classify the emotion of the delivery. Okay. So I'll talk a little bit more in detail about my speech emotion recognition model now, and some of the challenges that are involved in that. First off, I'm only focusing on emotion recognition from speech. That's because even though we do have the videos, this actor isn't always in frame. You can't always see their face. So we're just focusing on the speech part. I start with a pre-trained speech model called Wave2Vec2, which has been pre-trained on hundreds of hours of speech audio. It learns like a general speech representation, task agnostic. And then I fine-tuned that model using the MELD corpus. This is a commonly used corpus comprised of utterances and emotion labels from the TV show Friends. And there are 7 different emotions and each utterance is labeled with one of them. Here's some technical details on the slide if you're interested, but the bottom line is that the model achieves roughly 50% accuracy on a 7-way classification task. This more or less matches the state-of-the-art performance for the MELD corpus in the context of audio-only speech and motion recognition. Obviously, 50% isn't great, but when you consider that random chance between 7 choices is just 7% or 14%, we're clearly learning something here. And there's also a lot of work that shows that you can greatly improve the classification accuracy if you also include the words that are being said as input. That doesn't help us, though, because we don't actually want any textual priors. In fact, we're interested in how the same words might be delivered differently, right? So for our purposes, we explicitly don't want the words being said to affect the judgment of emotion. Okay, so that's the audio pipeline. Now I'm going to talk about the text pipeline, which is thankfully a little bit simpler. We start with the text that we transcribed in the audio pipeline. And so these are all the words that people said. We compute semantic embeddings for each of these utterances using sentence transformers. This is a vector representation of the meaning of each utterance. And then we can cluster these embeddings if they're semantically similar. So going back to the kind of organization of data that we wanted, we see that we get the individual utterances by transcribing the audio. We get the emotion labels from the speech emotion recognition model. We cluster the utterances into these phrase groups, and we have the raw audio from the speech segment. I guess quickly, any questions, confusions about this kind of process? Nice. Okay, so now that we have the process data, let's take a look at some of the results by playing a game. I have 4 different recordings of an actor saying some variant of "What are you doing?" And I want you guys to guess what the emotion label is. The audio plays immediately, and also like clearly there's like some wonkiness. So we'll tell them. Not very well. Let's see if let's try. Yeah, I don't think that's gonna work. Okay, well, we'll skip this part. Well, yeah, I don't think that's gonna work. I guess the point of this exercise was to show you that there are clear differences in the way that these actors deliver the lines, and the model picks up on those and assigns them different labels. And you can usually see that, like, yeah, that makes sense. However, there are also like definitely like ambiguous cases where, you know, multiple labels could apply. So it's a challenging task for sure. And the model does its best.
Can I ask a question?
Yeah.
When you trying to like validate it, or like you say it makes sense, are you
Yeah.
just listening to the audio, or are you also watching the movie? Because I imagine there's additional context that provides insight into the actor's state.
Yeah, that's a great question. I'm just listening to the audio in my best attempt to be like the model. But you're right. Yeah, and that context matters a lot in both like you know, the model performance potentially, and also like in how we like interpret the emotion on the screen, right? So totally. Okay. Moving on, I guess. I have in my notes that was fun, but you know, debatable. The real question though is like, what can we do with this kind of information? Ultimately, I want to use it to better understand the relationship between what's written down in the script and what we see on the screen, right? And so one way that we can do this is by looking at which phrases actually have greater capacity for variation. So I operationalize this by measuring the entropy in the distribution of emotions for phrases that occur frequently. So here I've plotted the distribution of entropies, as well as some examples of low entropy and high entropy phrases. You can draw your own conclusions from the examples that are shown, but I'll offer my interpretation of these results, drawing on some ideas from conversation analysis. So in conversation analysis, there's this idea of the adjacency pair and of preferred and dispreferred pair parts. Essentially, there are some conversational turns that expect certain preferred responses or perform a specific purpose. If I say hi to you, you'll probably say hi back. If I ask you for the weather, you'll probably tell me the weather and not like your name or something. There are other utterances that have a lot more room for variation. And so the pattern that I see here is that the low intensity phrases tend to have well-defined discursive functions, offering appreciation, seeking feedback, demonstrating politeness. The high variation phrases, on the other hand, are more general. In the case of come on, there are actually genuinely different multiple senses of meaning. I could say, come on. I could say like, come on, let's go to the Ph.D. reception. Or I could say, come on, do we have to? And so you kind of see that bearing out in the emotions that each are labeled with. We can also look at the trajectory of emotions in narrative. So for this analysis, I took the first 120 minutes of all the movies. I plotted the proportion of total utterances each emotion took up for every minute. So just as a sanity check, we see that the neutral utterances are relatively stable through the 120 minutes. Doesn't change much, makes up the plurality of the utterances. On the other hand, when we look at the plot for joy, we see this U-shaped curve. So there are more joyful utterances at the beginning and towards the end, but here in the middle. And if we look at surprise, it has almost the opposite trend. It's highest around 10 or 15 minutes in, but it diminishes over the rest of the time. Cool. I'll spare you like the speculation of interpretation. Yeah.
Wait, what? The y-axis?
The y-axis is the proportion of the utterances in a given minute that that surprise takes up. Yeah. Does that make sense? Okay. Cool. So those are some like preliminary findings. I think like they're pretty neat to show you guys today. But obviously there's a lot more to be done. The first is that, again, the emotion recognition model is less than stellar. And one easy way to improve it is to fine tune on some of our own movie data, which is a lot more in domain. So the MELD corpus, it's a good data set because it comes from a TV show. So it has a similar production value. It's similar in that way. But there is a limited cast, right? And as far as I know, the Friends characters have never been to war or, been in a jungle or any variety of other acoustic settings that show up in our data. Of course, the other thing is I'll be running this pipeline on our full movie corpus, which includes over 2,000 movies. And so we'll have a lot more to look at. And of course, there's a lot more analysis to be done as well. So I think I definitely want to dig deeper into both of these preliminary findings that I showed you today. But I think there's also interesting questions to be asked about actors and directors, who has license and range to be creative in their deliveries. Like the directors play a very significant role in all of this because, they tell the actors what they want to see. And also they dictate the final cut of the film. Right? I'm also interested to hear what kinds of questions you guys might have after seeing this kind of data, right? That's all I've got for you today. I have this video extrapolating from prior experience. I don't know how well it worked, but yeah. A lot of people say thanks. And I'd be happy to take any questions now.
This is just very funny. This is not a question about your research really, except to say that the other night I was watching a YouTube and it was Tom Hanks in front of an audience in like UK, Oxford or something. He's teaching them drama and he had them collectively say, how are you doing? Is that where you got this idea? Or are you seeing it?
I haven't seen it, but like, yes.
Because he's telling them first say it one way. You can't say it the same way each time. He has them say it about 6 different ways.
Yeah.
And it's a really interesting exercise. So independent.
Yeah, I think that sort of exercise, yeah, I guess maybe not that clip in particular, but that kind of exercise is definitely like the inspiration for this. Yeah.
I'm not sure how to word this question, but I imagine that a lot of dialogue happens between two people.
Mhm.
So can you tell me about your thinking about how this works, either like in isolation or between
Yeah.
characters or?
Yeah, totally. And right, so this is the way that I set things up. I'll go back to like kind of the slide where I showed it set up. The way I've set this up, right? Like ultimately what we're interested in is like given like a line that has some distribution of possible deliveries, how did an actor choose to deliver it in this case, in a particular case, right? And you know, the way they set it up here is that like we look at each individual line and the ones that are like similar, right? But you can easily imagine that within a context, the same line might have like very different expected deliveries, right? Like if I said hello and you responded hello, that would be very different from if I said, what are you doing here? And you responded hello, right? You know, just looking at the script, you would already expect to have a different kind of performance.
Or about talking to a child or.
Yeah, totally. And so this is kind of like the first order approach of doing this sort of like modeling the distribution of possible emotions. But the higher order approach would be to try to like model this within the context of like a series of dialogue turns, right? And seeing like, you know, given like the first 4 lines of context, how would you say like this next line, right? And what's more than that, you know, there's not a great reason to just say like all of the hellos are put together or all of the I'm sorry's are put together. Instead, you might consider like we have a more general like conversational emotion recognition model, right? And you just say like for a given line, whatever it may be, like can we predict the distribution of emotions, right? And what we're really trying to match on, which the semantics of the utterance is just a proxy for, is like we're trying to match on similar emotion distributions. Yeah.
I'm wondering what the purpose of the classification is, because we have, you know, many years of sentiment analysis for text. With the audio and movies, you have a possibility for a much better, wider range. And yet those categories, I think most of them were wrong for everything you're showing, right? Because sorry, it'd be apologetic or sarcastic or something like that. Usually probably not joy or sad, right?
Yeah.
Hello, maybe it's happy some of the time, maybe you call it neutral. But really your first example of Luke, I am your father.
Yeah.
That's not joy, that's not anger, that's, you know, some complex combination of triumphant and, you know, I mean, you can't even put it into words. So if you're looking at movie data, I'm kind of wondering, why is it okay to do these really coarse categories of sentiment versus, and it's only 50% on those, right? Versus like being more nuanced about it, even though I know it's hard to do.
Yeah. I think that's a great question. For I guess for the first part, all of these labels I just like threw up there as demonstration. None of these came from the models.
No, I just meant the set that you have available to you, the 9 or do you have more than 9 labels?
The 7?
Yeah.
Yeah.
7 labels.
So I actually tag onto that a little bit. I'm not sure.
Yeah.
Is your goal prediction of emotional distributions? Is that what your goal is? And what will that be useful for?
Yeah. So, you know, we're looking at emotion kind of as this like simplified, as a simplified problem or a simplified task for like this much richer, much harder thing that we're interested in, which is kind of like all the different aspects of your spoken performance, right? And so, you know, I talked about this a lot in my meetings with David because you're right. Like you know, these are very coarse categories. Honestly, like they're the models don't work great. And the actual like output of knowing like, is this happy or is this sad is whether that's interesting is kind of up for debate. But the thing that we're interested in, which is like how these paralinguistic features like occur in the speech, right? I think emotion is a good proxy for. And the challenge with looking at like just the raw paralinguistic features is that, you know, like it's features are hard to come by, right? And so one thing that I had like considered was like looking at just the raw like speech representations that we get, and like trying to compare those. You get like these challenges of having to control for like the speaker, having to control for like all these other things, which like kind of through this task of emotion recognition, we can kind of control for because like that's like marginalized out, right?
I suggest
yeah.
a slight modification of the approach, which is to condition the emotion recognition on the actual word or phrase. So for example, have a sorry model, have a hi model, and change what the labels are. I know it won't work with the friends thing, but maybe you could get actors or people to just do variations. Because I think that, first of all, you don't have to capture the whole range for any word, but really maybe focus on words that tend to be signifiers.
Yeah, I guess I guess I have to think about that a bit. I've been very reluctant to do like text conditional classification because again, like we want to know like for a given path, like a given text, like what the range of variance is, right? But yeah, I take your point, and maybe like if we only look at one kind of utterance, we might find like more meaningful variation in the margins there. But yeah, I guess like the challenges with like working with just the speech features remains. But yeah, no, I agree. Like that's kind of like the big question that I've been juggling. Yeah, maybe last question.
Yeah, so I'll keep it brief. I just want to riff on that as well. I think that the one thing that stuck with me, just in terms of methodology, is somebody works with transcriptions all the time, that 50% accuracy on meld. I'm wondering if some of that could be attributed to faulty transcriptions. I don't know what your experience is with Whisper, but I found it to be, in the smaller instantiations of that model, to be incredibly inaccurate.
Yeah.
And often inconsistent and also very slow. So I'm just wondering if you've got any thoughts on like the errors you're seeing in the transcription process.
Yeah. So yes. So I guess there's a couple parts here. The first part is for the meld corpus. That corpus was constructed using the Friends subtitles. So I think there should be fewer transcription errors there. And then and I guess we don't do that part. And so the second part is just about transcription accuracy outside of like the you know, the 50% validation metric, which is like in our test data. I guess, yeah, there are definitely incorrect transcriptions. I think for the most part, it's not bad. I think the biggest problem that I have right now is that it also transcribes music, and I don't want that. But we also don't use the transcriptions for the emotion recognition, specifically because we don't want to use the text for the emotion recognition. So I guess those are kind of like adjacent parallel problems, but hopefully that sheds some light. You have time. Okay.
The mixed space is very important, and I understand that you want to pick up what is like these changes in these waves that relate to these solutions. But I think it would be interesting if you could do embeddings of like computer vision based embeddings of like things and introduce them as features, like visual features, and see actually how much this helps prediction or not.
Yeah.
I know this is not the ultimate goal of this, but it would be nice also like to mimic maybe how we humans make sense of things, if actually like the ML algorithm actually also is capable of like making sense of like the visual features.
Yeah, yeah, for sure. I think that is definitely interesting. I guess for this project, I am interested in like the one specific part of this like entire performance, right? Which is like the spoken oral performance part of it. But yeah, I think like, you know, in this broader space of like computational film analysis, like the visual aspect of it is just as important, or probably like much more so, right? And definitely like lots of interesting work to be done there, especially you know, with a giant movie corpus. Yeah. Cool. Thanks. I think we're out of time.